Okay, so just to recap where we were, we moved from AS, where we're able to expand something with a whole number here, and that is literally expanding a bracket, isn't it? To this rather odd thing where we're being asked to expand this. It's helpful, I think, not to think of it as an expansion, but think of it as an estimation. But it's really odd because we're writing something that's being cube rooted as a succession of terms which involve x, x squared, x cubed, x to the power 4, etc., etc. It takes a while to get your head around it. The key thing to remember is that this thing has to be small, and because it's small, as we move up and the powers of x get bigger, a high power of a small number is tiny, so we can sort of ignore it, and that's why we rarely go beyond x cubed. So in this expansion, our x is actually 2x, and the power is a third. And I asked you to do the first 4 terms, so I'm a generous sort of person. I'll do the first 2 terms, all right? So that's half the work done for you, all right? So the first term is 1, and the second term is that times that. So that's, and I think rather than putting times, I'm just going to write a third times 2x. I'll put it in brackets. So there you go. So I've done half the work for you. So, come on, Isabel, do the next
Found
term.
out what I was doing wrong.
So go on, tell me what the next term would look like.
Will you let me work it out?
Well, no, just don't worry about working
okay,
out.
A third bracket. Minus 2/3.
Very good, yeah. Divided by,
2.
multiplied by,
A third. Oh no, 2x squared.
2x squared. And it's really important you remember that that is not 2 lots of x squared, that is 2x times 2x. And we'll come back to that in a minute. So go on, Jodie, give me what the next term would look like in sort of those sorts of terms.
Is that the fourth one?
So 1, 2, 3, the 4th term, yeah.
A third, open brackets, a third minus 1.
Which is?
Oh, minus 3. And then
Minus 2/3, yeah.
third minus 2, which is a minus 5 over 3.
Minus 5/3, that's right. Over?
6.
1 times 2 times 3, yeah, 3 factorial, brilliant, yeah. Multiplied by?
2x cubed.
Fantastic, yeah. And never try and do too much in your head. Don't try and work out what that actually is as you go. Always write that down, and that's there on the formula sheet, although this is really confusing, but you'll get used to it. We're going to do lots of practice. So let's now sort all this out. And of course, at this point, we can reach for our calculator to help us. And you know, there's nothing wrong with that at all. But you know, I'd always try and do a little bit in my head if I can. So obviously that's 1. A third times 2x, I'm just going to write that as 2/3 of x. Which, remember, is the same as 2x over 3. So, you know, which is better? I don't know, but whichever you prefer. Here I've got minus 2 over 9 divided by 2, which is minus 2 over 18, and that's multiplied by 4x squared, 2x times 2x. So I've got 2 over 18 times by 4, which is 8 over 18, but I can simplify that to 4 over 9. And that's a minus, so that's minus 4 over 9x squared. And if you're not sure, you know, work out your calculator, hit the fraction button. You've got sort of fractions within a fraction, so I'm going to do on top, you know, 1/3 times minus 2/3 divided by 2, and then times by 4, all there, all good. So that's 4/9. And then this term here, I've got, well, the first thing to note is it's going to be positive, isn't it? Because you've got two negatives. So I've got 10/27 divided by 6. So that's going to be two fraction buttons, 10/27 divided by 6, 5/81. And that's going to be multiplied by 8x cubed. So I'm going to multiply this by 8. So that gives me 40/81 x cubed. And I can stop there because if this is a small number, then x squared is going to be an even smaller number. X cubed would be smaller still, and x to the power of 4, it'd be so tiny it's barely worth worrying about. And often we're asked about the validity of this expansion. For what values of x does this roughly equal this? And you remember this thing has got to be between -1 and 1. So in this case it's valid when 2x is between -1 and 1. So that means x would have to be between -1/2 and 1/2. And why is this on the syllabus, this rather odd way of writing a cube root or a square root or another statement with a non-whole number power as an expansion of terms? But it's because how your calculator does it. It's how your calculator does a cube root. So if your calculator wants to work out the cube root of 1.6, it would make x equal to 0.1, and it would do a similar sort of expansion. Probably do more terms, but that's all the calculator does. The calculator does not have a massive great lookup table with every other cube root under the sun. It has a way of calculating it, and it's really easy to write a computer program that sort of automates that. So that's why it's on the syllabus, just to sort of expose, to give you a little look under the bonnet as to what actually happens here. So we're going to carry on practicing. I printed a couple of extra formula sheets, which we did all get. Don't have to take it, no one. So we're going to do a few together. Forgive me for sticking together today. So can we have a go at this one? And I want the first 4 terms of this.
Is R just like the next number?
R is the yeah.
Is it like?
Yeah, that's why I think it's really confusing. I mean, if R is as far as you are going to go.
What is R in this one? 2.
So no. If we're asking
-5/3.
If we're asking for the first 4 terms, then R will just be 3.
Okay.
Because it's the power of x, isn't it? So the 4th term, because the first term is always 1. Now this doesn't look like this, does it? It doesn't look like that. So, but Beth, how can I rewrite that statement so it does look a bit like that? How do we write 1 over things as an indice?
Is it a negative?
Yeah, so it's the same as this. 1 over 1 plus 4x is the same as 1 plus 4x to the power of -1, which does look like this. X is now 4x, and n is now -1. So go on, see if you can write me the first 4 terms of the expansion using those values. Just like we did a moment ago. And this is much nicer because the power isn't a fraction. So your terms look a little bit nicer, I promise you. It's quite nice, this one, isn't it? Because the numerator and the denominator cancel out. So you get your minus 4x, but then you've got minus 2 divided by, sorry, plus 2 divided by 2, which is 1. So you just end up with that. So that's 16x squared. And here you get minus 6 over 6, which is minus 1 times that. So that's minus 64x cubed. And in terms of validity, well, this is only roughly the same as this if 4x is between minus 1 and 1. So that means that x would have to be between a quarter and minus a quarter. Now, you know, we're saying that this is an approximate value of this, but why are we bothering doing this? Well, let's do another example. I'm afraid this one's another square root, so it's not going to be quite as nice. But then I'll show you how we're then going to use it to an estimate. So I'd like you to expand the first 4 terms of this using the binomial. George, how am I going to rewrite that? Square root. How do I write square root as a power?
Half.
Power of half.
Yeah.
So do me the first 4 terms of that, and then I'm going to ask you to do something with that. So use the same formula. I've got another copy of it if anyone's lost their formula sheet. Make sure you're on the A level side, not the AS side. Make sure that you're making x equal to minus 2x. quite pretty, this. Unfortunately, if we did work out the next term, the fun is over. It's no longer, it doesn't carry on with halves. But yeah, so we've got this. So now what we're asked to do is something rather odd. We're asked to make x equal to 0.01. Now if you make x equal to 0.01, this actually becomes the square root of 0.98. So what this would give us is an approximation to the value of the square root of 0.98, which might be useful. And certainly if you type in the square root of 0.98 is how your calculator works it out. However, we're asked to use it to find an approximation to root 2. So just do that for me. I mean, the way I would substitute 0.01 into this is I would type 0.01 arrow x, and then I would just type this into my calculator, and it would do it for me. George, you're looking troubled.
I'm always looking troubled.
Where did you slip up?
Everywhere.
So you can type this on your calculator, can't you?
Yeah, but I don't know how you get that.
You don't know how I get it. So okay, so the formula says that you've got n times n minus 1 over 1 times 2. So the next term, which is this is what this is trying to tell you, would be n times n minus 1 times n minus 2. And not over 1 times 2, but over 1 times 2 times 3. And it's not being multiplied by x squared, it's being multiplied by x cubed. So, and it's always going to be like that. And in fact, I can't ever remember, well, that's a lie. I can remember a couple of questions, but it's very rare you're asked to go beyond that.
Yeah.
But even if you are, the pattern continues. It would be n minus 1, n minus 2, n minus 3 over 1 times 2 times 3 times 4 times x to the power of 4. You'll get, honestly, we're going to do so many of these.
But then if n is a half.
Yeah. So you have a half minus
half minus 1, so you have a half times minus a half.
Oh, yes.
That's right, yeah, which is minus a quarter.
Yeah.
Divided by 2, which is minus an eighth.
Yeah.
Multiplied by 2x squared, which is 2x times 2x, which is 4x.
And then that's how you got.
So the 4 is, yeah. So it's,
but then how do you get minus a half x? How
This
do you
one.
get half times minus 2x?
Do you want me to do it now?
that was the second term, which is n times x.
Right.
So the first term is always 1, second term is n times x,
Yeah.
then it gets complicated. First two terms are always really easy. Okay. So Pat, have you managed to substitute x's 0.1 in? Has someone managed to substitute 0.1 in? What did you get?
0.9900495. 00495.
So what we've done is we've substituted 0.01 into that expression. Okay, and Isabel's got that. I have no reason to disbelieve her. I think I must have done it earlier in the day, so I can probably. Oh no, I can't. Oh yes, I can. No, I can't. And so what we're saying is that is an approximate value for the square root of 0.98, because we've expanded that and then made x equal to 0.01, and 1 minus 2 lots of 0.01 is 0.98. And if you could quickly actually work out the square root of the actual square root of 0.98 on your calculator, you can see what sort of estimate it is. Is it a good estimate? Is it a bad estimate?
Very good.
Now, you sure that's what you got? I'm sure it was better. Hang on a minute. Let's just do 0.01 to x. 1 minus x. Oh no, sorry, I apologise. So it's an okay estimate up to 2 decimal places, and that's not bad, is it? That's not bad. If we wanted to be more accurate, we'd do more terms in the expansion. However, where on earth does the square root of 2 come from? We've estimated the square root of 0.98. How are we going to use that to work out the square root of 2? And this is quite a neat trick. Hey, you're right, Gracie.
Yeah, it's just got different ones.
Right. Let's have a look. Does anyone else agree with me and Isabel? You get that?
I got closer on this.
Oh, hang on a minute. You've got yours is mine. Oh, yeah, this is me. I'm a doofus. That's a minus, isn't it?
Oh, I've just been copying you sometimes.
Oh, don't copy me. No, that's your first mistake. Yeah, of course, because that's going to be positive, isn't it? Thank you, Grace. Do you know what? We did it this morning and we got it right to 5 decimal places. That's why. So let's just change that. So I need to change a plus to a minus. Much better. Much better. Yeah. So now it's correct to 7 decimal places, which is much more what I was expecting it to be. So if I actually work this out on my calculator, I pretty much get that. So we've estimated this using this binomial series expansion. But how do we use it to find the square root of 2? It's a neat trick, all right? And I don't want you to scare you by getting to do this, but 0.98 is 98 hundredths, isn't it? And one of the first things we learn when we do surds is that that can be written as 2 separate square roots. Now I know what the square root of 100 is, it's 10. If you do root 98 on your calculator, it simplifies it for you. Because 98 is 49 times 2, and I know the square root of 49, it's 7 root 2. So what we're saying is that 7 root 2 is approximately that. So if I take that and multiply it by 10 and divide it by 7, I get an estimate for the square root of 2. And that's what the question was asking you to do, to multiply by 10, divide by 7, you get and go on, try that and then compare that with the actual square root of 2 to see how accurate it is. So all we did was, let me show you that path, we said, okay, we've used the binomial series expansion to work out 0.98 square rooted. If I know that, what other square roots can I work out? And you can actually work out the square root of 2. And of course, I'm saying that's the actual square root of 2, but it probably isn't, is it? That's the square root of 2 to 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal places. But of course, the square root of 2 is an irrational number. It will go on forever, like pi, in an unpredictable way. So all that this shows is that the calculator has worked this out using a series expansion where they've done more terms than we've done. We've only done 4 terms. They might do more. And there are other expansions you can use, not just the binomial. Anyway, we've estimated this. How close were we? Well, we can work out the percentage error if we wanted to. Depends who your teacher was. Most of you, I was your teacher, so when we were doing percentage change, we always did the after divided by before, rather than actually working out the change. But you might, at a different school, have been taught to do change over original. I'm going to do after divided by before, and by that I mean this is my estimated answer, so that's my after. And I'm going to do that over the actual answer to the square root of 2, or as my calculator tells me. So that's the effect. That's effectively change. After divided by before. So just get that on your calculator screen for me. So I've got the not this answer that the expansion gave me on top, and the actual answer on the bottom. Now that's the multiplier. Now of course we haven't done percentages for a while, but if you'd got 1.05, you would have known that was a 5% increase, so it's a 5% percentage error. So what's this as a percentage error? Well, that would be 1%, so I've got 0.0000000%. So 0.00006% out. That's not bad, is it? That's not bad. That is 1, 2, 3, 4, 5, 6. So that's 6 times 10 to the minus 7% error. It's not bad. It's not bad. So the alternative would have been to work out the difference, so that would be that minus root 2 on top over root 2, which would have given you that straight away. Rather than okay, one final one together, and then I'll give you a couple to try on your own. Right.
Does that say 0.2?
That says no, 2. So here I am being asked to expand this statement, and that's a 5. And this certainly doesn't look like that. Certainly doesn't look like that. However, if I rewrite it as that, I could say, well, okay, another way of writing this is 2 plus x multiplied by, well, how else can I write that? Well, it's the square root, and it's 1 over the square root, so it's the power of minus a half. So understanding that this can be written like this is a crucial step of understanding. So that's the first thing to remember. This can be written as this. Now this is just 2 plus x. That's not something I would want to expand, but this is something I can expand using that. So what I'm going to do is expand that using this rule. First 4 terms, because I'm asked to go up as far as x cubed. And when I get my answer to that, I'm just going to grid it out with 2 plus x. So I'm going to write my answer to this up here, and then I'm going to multiply it by 2 plus x. I'm going to grid it out and add it all up. I'm afraid the numbers are particularly fiddly. Stick with fractions, but don't use your calculator. Don't try and do too much manually in this particular case. So start by multiplying out 1 plus 5x to the power of minus a half.
Oh, so do we have to do the
Hello.
Hello, Chair. Literally 5-second question, which you might not be able to answer, but
first one is the multiplier of the 1 plus 5x. So we do the formula.
Got Sims open. Yep.
So formula first. Okay. So 1 is the first one. I mean, at the beginning of the lesson, George, I was looking at them.
I was too, but we
So come on, George, we'll do this together.
I just honestly.
So x is 5x,
It's just a breaking.
okay?
Yeah, x is 5x.
And n.
It's minus a half. Yeah, I got that.
So the first term, easy.
Yeah, well, 1 plus minus a half times 5x.
Second, no, the first term is just 1.
Oh, well,
So if you're asked for 4 terms, first term is just 1. Second term is those two multiplied together, yeah?
Yeah.
So I'm just going to write it like.
Yeah.
So there's the next one then, alright? So it's n times n minus 1. So what's 1 less than minus a half?
Well, minus 3 half.
Over 2.
Now you've lost me.
N times n minus 1 divided by 2.
Yeah.
N times n minus 1 divided by 2. Don't forget we've got to multiply it by x squared.
Yeah.
I just stopped up, drove down.
Okay, so the next term is n times n minus 1, so it's the same as what we've just written,
Yeah.
times n minus 2. So what's 1 less than that, basically?
Minus 5 half. Alright, that doesn't seem so wrong.
Multiplied by x cubed, and that's divided by 6, because it's 3, 1 times 2 times 3 you divided by.
Yeah, you say that. I just don't get how you do this.
And then whack all that into your calculator, and 5x cubed is 125x cubed, so just multiply it by 125.
I love this. So good.
Be honest with you, when I'm working it out, I don't worry about the negative, so I do that bit in my head. So for example, this third term, I know it's going to be positive, so I just do the rest of it because the negatives just confuse me. And don't forget, once you've typed this in, you can go and edit it to change it into that. So you can save yourself a little bit of work.
Oh, next time is 20. What we like.
You try. Well, keeps you.
Now, what I'm now going to do is take that answer and multiply it by 2 plus x. But the question says I only want up to an x cubed term, so I can ignore there where I'm going to get an x to the power of 4 term. Don't need to worry about that. Just been making a fuss over nothing, haven't you, George?
No, I still just. No, I've got a better understanding than I did at the start of the lesson. So. That's always a positive.
That's always a positive.
I can't believe it. Did you cue?
Now, if a mistake's going to happen, I wouldn't mind betting that it's going to happen here or here. Just got to make sure you force yourself to remember that, 5x squared is not 5x squared. It's 25x squared. And 5x cubed is not 5x cubed. It's 125x cubed. It's 5x times 5x times 5x. And there we go. Now, I realise that this is about as abstract as it gets. We're taking one horrible bit of algebra and changing it into another horrible bit of algebra, and it doesn't even equal the same. This is just an estimate for this. It's a pretty good estimate. We were 0.000006% out in the last question, but it's pretty abstract. But it is at the root of how calculators and any sort of computing device does more complicated calculations. So that's why they included it, just to give you this little sneaky look under the bonnet. Right. So let's let you get you to try a couple yourself. So 4 and 5 on page 96. I suppose giving you a book would be good.
I don't think this is an alone topic. Is this going to be 8?
There will be a question on some blocks, yeah. But it probably won't be as easy as it probably won't be as easy as we do.
Oh, I didn't have to. I really have to wrap my brain. I guess I'm
Everyone's so good. Let's just say there's people just seem to just be talking about I was that? And they were like, told you would have been more. I don't know if
Big fan of Flashdance, George?
Yeah, just right,
80s music is as good as it gets. That's,
honestly, I actually love like 70s, 80s, even a bit of the 60s.
Give us a sample, George.
I'm quite alright. I don't want to be known as that weird kid in the corner with like old music.
old
You
music.
already told us you like the music.
Yeah, we
Yeah.
just embrace it.
I'm not embracing
So, can you see the trick here? What you need to do is to rewrite it as that. And this doesn't need to be expanded. That's just 1 minus x, or sorry, 1 plus x. But that can be expanded using our new rule on the formula sheet. X is minus 2x, be aware, and n is minus 1. We're asked to expand up to the x cubed term, and they even give you the answer. And the fact there are no fractions in the answer, that'll make you feel nice. When n is minus 1, this is a whole lot easier. I'll just make a note. Make sure the example in the mock doesn't include n is minus 1.
I'll put it down, put it nailed down. I just stole it.
How is the second term 3x?
Don't forget that's when you've multiplied it by 1 plus x. So
Oh,
that's,
right, yeah,
that's the
got it.
final answer once you've grid it out and peanut it.
This is such a nice value.
Because it's got a bit of
Yeah, 1 times minus 2 times minus 2. Minus 2x squared.
Yes. Right, so that becomes positive, because minus 2x plus minus 2x is plus 4, and then you're multiplying it by 2 negatives, makes so it stays positive. This will be negative, but then you've got a negative which makes it positive, then a negative which makes it negative, then the negative makes it positive again. Now, the bit about validity, obviously the 1 plus x, no issue there at all, but the bit that we expand, that has got to be between minus 1 and 1. So 2x or minus 2x has got to be between minus 1 and 1. So the valid values for x in this question are, and you do sometimes get questions where numerator and denominator are both things you expand binomially. If you're then asked about validity, you say whichever of the two validity things is the harshest. So if one is valid between minus half and a half and one is valid between minus a quarter and a quarter, it's minus a quarter and a quarter.
Oh, this is just like really long question.
I know, but it's the thing is it's always the same. I know the numbers vary, but it's you know, potentially could be one of the more straightforward things.
Oh yeah.
And that it's ways
So, can I ask you to have a look at question 5 ahead of next lesson? It looks scary, but all you've got to do is to expand 1 plus 3x to the half. They've already given you the validity statement, but that doesn't throw things. You've then got to substitute in x is 0.01 and work out a percentage error. So it's a scary question, actually isn't that scary. I've set you a homework. I was going to set you another sequences homework, but actually I'm really keen that you get into the mock revision. So what I've done, I think I've been quite clever. This week I've encouraged you to look at sampling, where we're going to start from now. SUVAT, partial fractions and functional transformations, and so the homework just includes one Maths Genie question from SUVAT, partial fractions and transformational functions. You may already have done them. So it's just nudging you in that direction and just giving me some confidence that you're engaging in that.
When is the last one valid?
The last one is valid because this is the bit that we expanded.
Oh, so you only got.
So that has to be the 2x has to be minus 1. So it's between minus and
Why
half.
don't you put minus 2x?
Well, you could do, but it makes no difference.
Oh.
It makes no difference.